for all others. Okay, we will start now. So why attendance is low? Just wait for a few seconds. That okay. In the last lecture, we have completed up to the. I think we have finished the filtration. Okay. Now we will turn towards this B part, that is disinfection process. Okay. So we will learn about the disinfection process now. So I will switch over to that slides. Okay. Disinfection. Next point is the disinfection. What exactly we are going to study under this is the first thing, disinfection. What is the mechanism? What are the factors affecting on the disinfection? Okay. Then what are the different types of disinfections? Types and methods of chlorination. Okay. And then breakpoint chlorination, bleaching powder, and chlorination. This much part we are going to study in today's lecture. Okay, so disinfection is simply killing of bacteria. Okay, so I told you during the filtration process, in a filtration process, what we are doing, we are removing the suspended solids or the turbidity or the dissolved impurities, organic materials from the water with the help of microorganisms, and hence we have constructed the sand beds on which the microorganism can grow and they can decompose the organic impurities, which we are not able to remove by simple filtration method or by any other methods. So that's why we can remove that with the help of microorganism in a filtration process. And because of that, in a rapid sand filter, there is a possibility to have the microbial contamination after filtration. And hence that microbial contamination must be nil, 100% nil. Okay, not single microorganism is allowed, because metabolism rate for the microorganism is very high. A single microorganism, single bacteria may go for the thousands of bacteria within few minutes, hours. Okay, so that's why this is very dangerous to have the growth of microorganism in water. That's why it must be killed by us. And that's why we should go after the filtration, we need to go for the disinfection process. Now, what are the different disinfection methods that we are going to study in detail? So what I explained now about disinfection is wrote on this board. So I request you to write down the title of the today's lecture as disinfection. So what is the disinfection? Yes, anybody want to talk? Okay. What is the disinfection? The filtered water may normally contain some harmful diseases, disease producing bacteria in it. These bacteria must be killed in order to make the water safe for drinking. The process of killing these bacteria is known as the disinfection, or we can also say this is a sterilization process. Understood? Okay, so whatever I explained now, that is what in short written in this PPT. So I request everybody to write down the definition of disinfection fast, so we can go for next point. Okay, the process of killing bacteria is known as disinfection. Okay, Title of the today's lecture is the disinfection. And the definition in short, you can write down the process of killing harmful bacteria. You can write down the process of killing harmful bacteria is known as disinfection or sterilization. Okay. Now we'll see in detail the next part. So what is the next part? What are the different methods of the disinfection? Okay. What are the different methods of disinfection? Here in the disinfection, so there are the different methods. So the first and very popular one is nothing but the boiling. But it is possible to go for this method at individual level, because is it possible to boil the entire quantity of water which we are going to provide to the Pandharpur city? No, it is not possible. So boiling method is method of disinfection is applicable only at the individual level. Okay, so the bacteria present in water can be destroyed by boiling it for a longer time. Okay, we need to, we are not supposed to just boil and close the gas and then close the flame and then it will, you might you cannot think that 100% bacteria kill. After boiling point reached, then you need to go for boiling for a few more time, that is minimum 5 minutes you should allow to boil the water, then and then only the bacteria will get killed. However, it is not practically possible to boil huge amount of water. Moreover, it cannot take care of future possible contamination. So what is this? This sentence you might have understood. However, it is not possible to boil the water at the huge amount. But moreover, this is, it cannot take care of future possible contamination. Very important statement is this. Why this is important, I will tell you. So the concept is important. Boiling cannot take care of future possible contamination. Now, you are treating water in a water treatment plant. Okay, so you have gone for the first collection of water, then coagulation or sedimentation with coagulation, then you have forwarded that water through aeration done, flash mixing done, flocculation done, sedimentation done, filtration done. Now disinfection is also done, and then you are going to provide that quantity of water to public through the pipeline. Okay, as you are submitting water to the public through the pipeline, there is a possibility to have the recontamination. Though we have treated completely in a water treatment plant, म्हणजे आपण water treatment plant मध्ये सगळ्या बॅक्टेरिया रिमूव्ह करतोय, मॅक्झिमम अमाउंट ऑफ जे काही पोल्युटंट वेगवेगळ्या प्रकारचे आहेत ते सगळे रिमूव्ह केलेले आहेत. आणि जेव्हा आपण ते पाणी सबमिट करतो सोसायटीला थ्रू पाईपलाईन, तर त्या पाईपलाईन मध्ये रिकंटॅमिनेशन होतं. पाईपलाईन मध्ये रिकंटॅमिनेशन होण्याचं कारण, पहिलं कारण एक असतं की त्या पाईपलाईन मध्ये काल सप्लाय केलेलं पाणी, आपल्याकडं कशा पद्धतीची वॉटर सप्लाय सिस्टीम आहे, तर इंटरमिटंट टाइप ऑफ वॉटर सप्लाय सिस्टीम आहे. दोन प्रकारच्या वॉटर सप्लाय सिस्टीम असतात. एक म्हणजे इंटरमिटंट वॉटर सप्लाय सिस्टीम आणि दुसरी म्हणजे कंटिन्युअस वॉटर सप्लाय सिस्टीम. कंटिन्युअस वॉटर सप्लाय सिस्टीम मध्ये काय असतं की तुम्ही जेव्हा तुम्हाला टॅप फिरवलं की पाणी येतं, टॅप फिरवलं की पाणी येतं, म्हणजे कंटिन्युअस सप्लाय चालू असतो. आणि इंटरमिटंट वॉटर सप्लाय म्हणजे कसं असतं की ठराविक पिरियड मध्ये ठराविक लोकांना पाणी मिळतं. म्हणजे आता पंढरपूरचं उदाहरण घेतलं तर मनीषा नगरच्या लोकांना इतक्या वाजल्यापासून इतक्या वाजता पाणी येईल रोज. इकडे दुसरीकडचा कुठला इसबाईचा एरिया घेतला तर तिकडं कुठून कुठपर्यंतच्या पिरियड मध्ये पाणी येईल हे मेन्शन केलेलं असतं. आणि त्या पिरियड मध्ये मग जेव्हा नॉन सप्लाय पिरियड असतो, त्या नॉन सप्लाय पिरियड मध्ये आज सप्लाय केलेलं वॉटर उद्याच्या त्या सप्लाय पिरियड पर्यंत तसंच स्टॅग्नंट वॉटर राहतं, ते कुठंच जात नाही. बरोबर आहे का? आणि तिथं ते देर इज अ पॉसिबिलिटी टू हॅव द ग्रोथ ऑफ मायक्रो ऑर्गॅनिझम. बरोबर आहे. आपण घरात जरी पाणी ट्रीटमेंट करून घरात आलेलं असेल तरी 2 दिवसापेक्षा जास्त स्टोअर केलेलं वॉटर पितो का आपण, वापरतो का? नाही. कारण तिथं पॉसिबिलिटी असते की जे केमिकल्स अप्लाय केलेले बॅक्टेरिया किल करण्यासाठी किंवा प्युरिफिकेशनसाठी, त्यांचा स्टॅमिना संपलेला असतो आणि ज्या बॅक्टेरिया असतात त्याची ग्रोथ झालेली असते. अँड दॅट कॉजेस द recontamination. सो दिस इज द वन रिझन. सेकंड रिझन की बऱ्याच वेळा आपण बघतो की पाईपलाईन ह्या लिकेजेस असतात आणि जेव्हा सप्लाय चालू असतो त्यावेळेस सप्लायच्या प्रेशरमुळं आतलं पाणी बाहेर फेकलं जातं. त्यामुळे आपण बघतो की कधी कधी लिकेजनं पाणी असं उडताना दिसतंय आणि वेस्ट होते. दॅट विल गोज टू द अंडर द लॉसेस ऑफ वॉटर. पण जेव्हा नॉन सप्लाय पिरियड असतो त्यावेळेस तिथे कॅव्हिटी निर्माण झालेली असते पाईपमध्ये आणि पाईपमध्ये जी कॅव्हिटी निर्माण झालेली आहे त्याच्यामुळं काय होतं की बाहेर जे काल उडालेलं पाणी आहे जे खराब झालेलं आहे ऍटमॉस्फेरिक आणि सरफेसवरच्या कंटॅमिनेशन मुळे ते परत त्या लिकेज मधून एंटर करतं आणि त्यातलं पाणी रिकंटॅमिनेट होतं. आणि जेव्हा नवीन सप्लाय येतो त्यावेळेस काय होतं तर त्या पाण्यात ते पाणी मिसळतं आणि रिकंटॅमिनेशन होतं. बरोबर आहे. तर ह्या रिकंटॅमिनेशनची एक स्पेशल केअर घ्यावी लागते आणि ती कशी घेतली जाते हे आपण क्लोरिनेशन मध्ये बघणार आहे. ओके, so you remember this point. Understood? Understood? I want yes, yes please. कळालं का?
Yes, ma'am.
Okay, thank you. Now we'll go to the next slide. Boiling. First method of disinfection, you know the boiling. Okay. Second method of disinfection is use of lime. Excess amount of lime we need to use. Okay, lime is used in water treatment plant for softening, but if excess lime is added to the water, it can in addition kill the bacteria also. Lime when added raises the pH value of water, making it extremely alkaline. This extreme alkalinity has been found detrimental to the survival of bacteria. This method needs the removal of excess lime from the water before it can be supplied to the general public. Treatment like recarbonation for lime removal should be also used after the disinfection. I don't know how much you understood through these lines. I will explain. Okay, use of lime is for what purpose? For water softening purpose. Okay, so calcium carbonate and calcium carbonates and bicarbonates of calcium and magnesium reacts with lime and they converts into PPT, that is precipitate, and starts settling down. That means this process helps for the removal of hardness of water, and that is what mentioned in the first line. Application of lime is used for the treatment plant for water softening. Okay, water softening can be done by this way. But if you use excess amount of lime, then it will convert. Lime's nature काय? Alkaline nature. So because of that alkaline nature, it will be that excess quantity of lime will convert that water into alkaline nature. And in a highest alkaline level of water, the bacteria will not be survive. Okay, so there will be found detrimental to the survival of bacteria. They will not survive, and because of that they get killed out. Okay, so this way disinfection is possible by using the excess lime. But what happens due to excess lime? There is a huge amount of solid waste will generate. तुम्ही लाईम वापरताय, पाण्यामध्ये लाईम टाकताय, मग लाईम मध्ये जसं ते अल्कलाइन नेचर तयार करते त्याच वेळेला त्याच्यामध्ये सॉलिड पार्ट खूप असतो. ऑलमोस्ट 75% solid waste will generate, sludge will generate because of addition of lime. Then you need to provide the method to remove that solid waste, that is sludge, that is lime, excess amount of lime from the water, and then you can make available to that water to public. Okay, also because of that, because of addition of lime, there is the excess amount of carbon is also generated in the water. And for that purpose, you need to go for the recarbonation for the removal of lime from the which is used for the disinfection purpose. Means these are the multiple drawbacks with respect to lime, and that's why we don't prefer to go for the lime addition for the disinfection purpose. Understood? So the first method, boiling. बरोबर आहे? So though we are treating water in a water treatment plant, uh, we uh, we cannot say this is 100% disinfected if it is not getting disinfected properly in a disinfection unit. Okay, and boiling is the one of the first method, but it is not applicable for the mass level, but we can use it for the individual level. And also another drawback with respect to boiling is it cannot protect the recontamination. म्हणजे बॉईल केलं समजा तुम्ही काहीतरी पुढे फ्युचर मध्ये रिसर्च झाला आणि बॉइलिंगची मेथड खूप स्वस्त झाली आणि इफिशियंट झाली, तर आपण वॉटर ट्रीटमेंट प्लांट मध्ये त्याला बॉईल पण करू. पण बॉइलिंग केलेलं वॉटर जेव्हा आपण सप्लाय करतोय त्यावेळेस त्या पाईप मधलं जे रिकंटॅमिनेशन आहे ते होणारच आहे. तिथं काय बॅक्टेरिया किल करण्याची मेथड वापरलेली आहे का आपण? नाही वापरलेली. मग असं काय वापरू शकतो का आपण? हो वापरू शकतो. आणि मग ते काय दॅट वी आर गोइंग टू सी इन द नेक्स्ट. So first one is the boiling, second one is the lime, which is not applicable because of many drawbacks as discussed here. So I hope you have noted down the second method for the disinfection is the boiling. Okay. Now I will go to the next. Okay. Third method. Treatment with ozone. Okay. Ozone readily breaks down into normal oxygen. Ozone readily breaks down into normal oxygen. ओझोन जेव्हा ऍटमॉस्फिअर मध्ये आणला जातो तेव्हा तो पटकन डिसोसिएट होतो आणि त्याचं काय होतं की ऑक्सिजन ऍटॉमिक ऑक्सिजन आणि मॉलिक्युलर ऑक्सिजन फॉर्म होतात. बरोबर आहे? देन अँड रिलीजेस नेसंट oxygen. The nascent oxygen is a powerful oxidizing agent and removes the organic matter as well as the bacteria from the water. So this method, third method for the killing of bacteria is the ozonation. You can please note down ozonation. So when you are adding ozone gas in a water, at that time it will start breaking down and convert into a normal oxygen and nascent oxygen, and that nascent oxygen is powerful oxidizing agent, and hence it will remove the organic matter as well as it will kill the bacteria from the water. So this is the function of ozonation process, and it is very highly effective process, but also equally it is highly costly method. How it is costly method? Because we need to convert the atmospheric oxygen into ozone, and then ozone we can apply into water, and then in the water it will start dissociation and convert into normal oxygen and nascent oxygen, and then nascent oxygen will kill the bacteria. Okay, so this is the flow path. But conversion of atmospheric oxygen to ozone requires a high cost instruments. First thing. Second thing, we need to convert the ozone at this plant itself. We cannot buy the ozone from somewhere and we cannot apply wherever it is required. Wherever it is required, there itself means on site it is need to be converted, and that extra setup needs to be added into the water treatment plant if you are using the ozonation method. Understood? So this is the drawback with the ozonation method. Very specific type of treatment if we want to go for to the water, at that time only we can use the ozonation method. Otherwise, at the public water supply system, it is not accepted. Any problem, any issue, any question, let me know. Otherwise, I will proceed. No problem? Okay, I
No,
hope
ma'am.
okay. I hope you people have noted down. Next method is the ozonation. Now we'll see the next method. UV radiation. Next method is the UV radiation. Disinfection by using the UV radiation. Ultraviolet light. Okay, use of ultraviolet light source which is enclosed in the transparent protective sleeve. It is mounted so that water can pass through a flow chamber and UV rays are admitted and absorbed into the stream. When ultraviolet energy is absorbed by the reproductive mechanism of the bacteria and viruses, the genetic material is rearranged and they can no longer produce. Very bigger advantage in respect of bacteria killing by using the ultraviolet radiation. But equally, same problem as mentioned in the ozonation. In the ozonation, we saw that there is a huge amount of investment is required for the separate attachment to convert atmospheric oxygen into ozone. Same here. For the disinfection purpose, by using the ultraviolet radiations, we need to use separate attachment and then a thin layer of water will be allowed to pass through the passage where the ultraviolet radiations are coming. And when ultraviolet radiations are coming and passing through this thin layer of water, at that time, it is penetrating. We should take care that the layer of or the thickness of water must be equal, must be very low to allow to penetrate the ultraviolet radiations up to the bottom. The penetration of ultraviolet rays must be done up to the bottom. Then and then only it will kill the entire bacteria. But the additional advantage of ultraviolet radiation is not only killing the current bacteria, but also it is killing the fertility of that particular microorganisms. Means there will be a direct impact upon the fertility or the genetic material of the microorganism, and hence there is no possibility to have the growth of microorganism in that particular tank later on. But there is also a recontamination issue. Ozonation, in the ozonation, up to some extent we can consider that the recontamination can be avoided by using the ozonation. Recontamination avoid करायचं म्हणजे काय करायचं, that you should understand first. So when you are adding some chemical or some agent in a disinfection tank, and after disinfection tank, you are making that water available to the society, and there is a water age. What is meant by water age? Time required to reach the water from water treatment plant to consumer point. बरोबर आहे? That period is known as the water age. मग जितकं water age जास्त असेल, for example, we can take the example of Pandharpur city. Water treatment plant established in the Manisha Nagar. Water reaching to the Manisha Nagar people, that water age will be maximum 7 minutes, 8 minutes. Okay. Water reaching to the people who are staying near the Vitthal temple, that water age may be 35 minutes, 40 minutes. Okay. So as the passage is longer, water age will be longer. As the water age is longer, there is a more possibility to have the recontamination. So as per the water age, we need to provide such a way, we need to take care of recontamination in such a way that it will not be getting recontaminated. So here, in a earlier technique, that is ozonation, if ozone is added than the required amount, at that time, that nascent oxygen may flow up to the end of the up to the consumer point, and hence it will not allow to get recontaminated during the pipeline. But here in the ultraviolet radiation method, when you are passing that layer light through the water, at that time it is killing the bacteria. It is killing the genetic material of that bacteria also. But we cannot say it will not allow to have the recontamination. There is a possibility to have the recontamination. And again another disadvantage, major disadvantage, method is very costly, method is very sensitive, need to be handled very carefully with the help of trained supervisors. It is not possible to handle by the common man. Okay, so these are the disadvantages with respect to ultraviolet radiations. Understood? Okay, so I hope you have noted down. The next method is the UV radiation or the UV light passing through the thin layer of water. Okay, if you have done, we'll go to the next point. What is happening? Okay, now the next one method is the chlorination, which is highly efficient, easily available, low cost, and no separate attachment, no skilled persons are required. Taking care of the recontamination of water during the path, everything is possible with the chlorination. And hence, this method is very popular one and accepted at the public water treatment plant. And hence, we are going to study in detail about the chlorination. Okay, so write down the next title, chlorination. Next method is the chlorination, and then next line you can write down the title, chlorination. The germicidal action of the chlorine is explained by the recent theory of enzymatic hypothesis, according to which the chlorine enters the cell walls of the bacteria and kills the enzymes, which are essential for the metabolic processes of the living organism. Okay, please note down chlorination, and then we'll proceed to the next slide. A lot of we are going to understand about the chlorination. Okay, I hope you have finished the chlorination point.